Hi everyone. In this video, we want to look at state of matters. State of matter. Learning outcome. At the end of this video, you will learn what matter is all about, the state of matter, plasma, forms of plasma, changes of state, comparison of the four states of matter, and magnetohydrodynamics. What is matter? Matter is anything that takes up space and has mass. It consists of tiny particles such as ions, atoms, or molecules. It's not everything that is matter. So let's look at example of things that are not matter. Things that are not matter, we have rainbow, we have light, we have heat, we have memory times, we have reflection, even love. It is not matter. So these are examples of things that are not matter and many others. So for anything to be matter, it must take up space, occupy space, and it must has mass. And like we said, matters are composed of ions, atoms, or molecules. So these are examples of things that are not matter. Okay, let's look at state of matter. Matter exists in various forms, which we call states of matter. And these depend on the particles arrangement, how the particles are arranged and move. So, from high school or secondary school, we learned that matter exists in three states, in solid, gas, and liquid. And there is a transition. Matter in solid state can change to gaseous state through a process called sublimation. Matter in a gaseous state can change to solid state through deposition. Solid can change to liquid through a process called melting. Liquid can change back to solid through a process called freezing. And liquid can change back to gas through vaporization, while gas can change back to liquid through condensation. So these were the three states of matter that is normally taught at high school or secondary school. However, there are four states or phases of matter. Let's look at them. We have earlier stated matter exists as solid, as liquid, as gas. Then the fourth state is called plasma. So these are the four states of matter or four phases of matter. Matter in the case of solid, like we earlier said, that the state of matter is based on the arrangement of particles and the movement of particles. Matter in the case of solid, the particles are compacted. As we can see here, the particles, they are compacted. Then, and it is cold. When heat is applied, we can see that matter in solid state will change to liquid state through the process we just mentioned, melting. And matter in a liquid state, see the molecule, they are not as compacted as the case of a solid. Then when heat is applied again, see matter in a liquid state can change to what? A gaseous state. And the molecules, they are well spaced, they are not compacted like the case of liquid or solid. Then when much heat is applied again, we see matter in a gaseous state will change to the fourth state of matter called plasma. And as we can see, in this state, matter exists as ion, positive and negative ion. And the major factor here is heat. Matter in the solid state is cold, in the liquid state is warm, and in the gaseous state is hot, while in the case of plasma, it is hotter. And plasma exists in the sun, in the star, electric arc, lightning, near sun, among others, because of the heat required. So these are the first state of matter and the changes involved. Okay, let's look at plasma proper. A plasma occurs when a gas is extremely heated or subjected to a strong magnetic field. So plasma is composed of very large number of free electrons and ions, like we just seen. So when a gas, this matter in a gaseous state, when it's heated to a very high temperature, it ionizes to free electrons and ions. And matter in this state is called plasma. So plasma is normally referred to as what? The fourth state of matter. And because plasma is ionized, it is a good conductor of electricity. Okay, let's look at what plasma physics is all about. It is a branch of physics that deals with plasma and their interaction with electric and magnetic field. There are different branches of physics. So the one that has to deal with plasma and their interaction with electric and magnetic field is called plasma physics. Let's look at various forms in which plasma exists. Plasma exists in as lightning, in aurora, low pressure gas inside neon signs and fluorescent light. We have it in a solar wind, welding arc, Earth atmosphere. Plasma exists in stars, including the sun. It exists in the tail of a comet. It exists in interstellar gas cloud, and also a fireball of a nuclear explosion. So these are various forms of plasma. We have looked at various states of matter. Let's look at, want to look at the difference. First of all, we need to understand collision, and before then, let's look at mean free path. We'll use mean free path and cross section to see how we differentiate the different state of matter. That beside the density, the compartment, we want to see other parameters that we can use to compare the four states of matter. So the first one we are looking at is a mean free path. Mean free path is the average distance traveled by a given particle between collision with the medium in which it moves. The second parameter we'll be looking at is cross-section, which is the measure of an effective area that a given particle will collide with other particles in the medium. So let's use these two parameters with the density earlier mentioned to see how we look at the difference between the four phases of matter. The first one is solid. In the case of solid, the density is the particles, they are very compacted, so the density is very large. The cross-sectional area is large, and the mean free path is very small. Mean free path, the distance a particle will have to travel before collision, because they are compacted, is very small. Then let's look at the second matter, the state of matter, liquid. In the case of liquid, the density is also large, but not very large like solid. The cross section is medium. The mean free path is small because they are also close, but not like the case of solid. Then in the case of gas, the density is small because the particles, they are not compacted, they are not close. The cross-sectional area is small. Then the mean free path is large because the particles, they are well spaced. They have to travel some distance before collision. Then let's look at plasma. In the case of plasma, the density is various, it varies. The cross-sectional area very large, then the mean free path also varies. Let's look at another thing, magnetohydrodynamics. What is it all about? Magnetohydrodynamics is a coupled Maxwell equation of electromagnetism with hydrodynamics to describe the microscopic behavior of conducting fluid such as plasma. Let's look at examples of magnetohydrodynamics. There are various examples. One of it is Faraday's law. And like we have said, magnetohydrodynamics, they are coupled equation of a Faraday's law of electromagnetism and the Maxwell equation. So one of it is Faraday's law. Another one is Ampere's law. We have continuity equation. We have adiabatic energy equation. We have divergence constraint. We have idea Ohm's law. So these are magnetohydrodynamics. In our next class, We will discuss more about the magnetohydrodynamics in detail, how these equations are derived, and how we can use it, the practical application. Thank you very much for listening. Please subscribe to my channel for more videos, like and share this video. Bye for now.